Okay, this is a problem switch on all 63 to 67 Corvettes. This is for the headlight motors, for the headlight buckets to roll them up and down. And the design was that all of the current for the motors, which is about 5 amps or so when all geared up and whatnot. It's a little bit more, but for each motor. So you get about 10 amps to 15 amps probably going through this switch, and the contacts on these switch get carboned up over time. And then you find out that you need to push harder and harder on the switch, and then some night after you get out of dinner and it's dark out, you go to roll the headlight buckets up and they don't come up. And then you got to go open the hood and turn the thumb wheels. I got them off of these motors right now, which is just turning the armature. So it takes you about 10 minutes for each side to get each headlight bucket up. And it starts raining. Anyway, so you know how it goes. All right, so what this contraption is something I designed many, many years ago. And I don't know, I finally got around to doing it. Since I don't do body off restorations anymore, I got to keep myself busy. So I drew up a little schematic one day having coffee and said, yeah, we can do this. So I got the parts. The pigtail for the switch, the harness, the main harness that plugs into this, it's got a special connector. It's a 3-pin connector. And now you can get those pigtails. They're available. The colors are not equivalent to what they were in 63 to 67 because the pigtail and connector is also used for 68 up Corvette and for the power windows. They went to the vacuum operated headlights on those cars, which is another discussion someday. But anyway, so those colors were blue and brown and red for the power. So as you can see, the blue is equal to the yellow for the 63 to 67 Corvettes, as the brown is to the green. And this is my little setup I made just a little while ago. And there's the relay box. So what I'm doing is, instead of all the power going through that headlight roll-up down switch, we're going through these relays. These are hefty relays. This is a box that I was able to get, and there's a bunch of them around. And it has 80 amp relays, which is way more than what you need, but for the sake of safety, those relays will probably never ever fail. And it comes with fuse points also. So if you put this in your car, and it's all plug and play, and by the way, I have a connector made up coming off of the relay box to plug into the pigtail that would be in the car, in the harness. Okay, this is what the harness looks like. Power comes from the circuit breaker, 40 amp circuit breaker, 30 or 40, I forget. And then it goes through the switch, and then it comes back to the headlight motors themselves via the harness. They go through the bulkhead connectors and out to the motors. And if you notice, they reverse the polarity of one motor versus the other. That's why you get one to roll up, and the other one will roll up, but in an opposite direction. As you can see in the diagram, all they do is they tie the yellow and the green together on the left-hand side of the car, and you see the yellow goes to that pin out on the motor. That's that connector on the back of the motor, the receptacle on the motor. And when it gets to the other side, it just goes to green for that side, so it reverses the polarity in the harness between the left and the right side. But anyway, this is the setup. I just have a battery. I'm doing my test setup. Power comes, this is effectively the harness that's in the car, and what you do is you plug this guy in. Plug and play. You plug this into the harness in the car. It supplies power to the relays, the input power to the relays, and also this bus. And there are, I use one of them to power the relay coils themselves. That's a 10 amp fuse. It also is fused. The inputs to the relays are actually fused, and it comes with hefty duty fuses. It's a 50 amp for each one for super heavy duty use. For those to blow, it would be a catastrophic failure. But the idea here is to run the power of the switch. Instead of running all those 12 to 15 amps, 10 to 15 amps through that switch, you're only going to run about 1/10 of an amp through the switch. And here's the way it works. You be in the car, and you can put this under the dash. You can tie wrap it up. All you need is a separate ground wire connected up to the kick panel sheet metal of the bird cage. I got it connected to my battery. Actually going through a meter right now to measure the current. But you can hear the relays when they click. Whoop. So that's down. So if you look carefully, you'll be able to see the left motor. I have two right motors here actually, but the way the motors work is just the hardware up front that alternates which side it's on. So you see this one's going clockwise and that one's going counterclockwise. That's in the down position. In the up position, this one will go clockwise and this one will go, that one went clockwise. Wait a minute, I got it wrong. Clockwise, clockwise, down. That one is clockwise. That one's counterclockwise. Okay, now in the up position, that one's counterclockwise, and that's clockwise. It was going so fast I couldn't see it. All right, but you get the idea. All right, so now, when they operate, is down, is up. Instead of 12, 15 amps going through that switch, now you're getting about 120 milliamps. So it's about 0.12 amps going through the switch. Is down, is up. The relay coils themselves and inside the relays will be a little different, but so it's about 0.12 amps per relay. And total current, that's total current. Because when I'm down, I'm going through one relay, and when I'm up, I'm going through the other relay. So it's the most you're ever going to get. You can't run both at the same time, because that would be an internal short inside the field coils. The motor wouldn't run at all. But anyway, that's the latest invention. And cost-wise, it might total. It's not going to be too bad. That's about $25. These pigtails are about $20 to $25 based on where you get them. So you only need one. And then the actual connector pins and making up a connector block, which I have a design for that. But that's about it for this is my mock-up test for testing the relay box. I had to make a few changes internally to the relay box. These extra wires are actually for these extra taps, so if you have something else that you want to run off of a constant power, because this would be constant power. Let me unplug my power and show you the back side of the box. Constant power comes in via this wire, gets distributed, and then these wires are the wires that go off to black is the ground, common for the coil, the relay coils, and the blue and the green, the yellow and the green are the outputs from the relays. Reds are the inputs to the relays, the heavy duty wires. And there it is. Okay, so the blue and the brown on the pigtail go into the headlight motor switch are my inputs to activate the relay coils themselves. Power comes in, and then the switch switches the relay coil power via the pigtail. This is a add-on pigtail. This pigtail would be the harness in the car. So you only need one pigtail. So for about 50 or 60 bucks worth of parts, you're probably going to save that switch, which is about 120 to 150 bucks based on where you get it these days. And it's not identical to the original switch. There are some features on it that are a little bit different, but at least it's available. Okay, that's it.